But good afternoon and welcome to the show and tell. Actually, this one is the last of the series in terms of round 2 alpha. And my name is Manu Ravishankar. I have the pleasure of leading this one and taking you through today afternoon session. So today's topic is we have a great set of projects looking at the very important topic of transitioning local energy systems, which we'll get to. But it's a critical area where, as we know, most of the research agrees now that we need some sort of a local approach to kind of dealing with the climate emergency. And we've seen that with different local authorities and devolved regions and administrations having their climate targets, which sometimes is much earlier in terms of compared to the national targets. And so it brings a lot of opportunities. Again, research shows that over hundreds of billions of pounds can be saved and a lot of time can be gained as well in terms of taking these local approaches. But of course, with local approaches, there's a lot of disparate activities as well that needs to be coordinated. So there's a lot of things that need to be brought together from a local perspective to kind of make this work. And that's what all of this session is about and all of these projects are about. And how we can use developments and the latest tech in terms of digitalization, thinking about institutional reform, so on and so forth, and how all of this can be kind of brought to bear to help us meet the climate targets in a more effective and a cost-effective way to consumers. So that's kind of what we'll be listening to from all of the great speakers in the projects today. So if we move on to the next slide, please. Thank you. And as I said, yeah, my name is Manu Ravishankar. I work for Innovate UK. I'm the head of Insights and Impact, and I'll be essentially helping kind of transition the projects from the presentations, and I'll be leading the Q&A. And please do, as the projects are presenting, as you think of questions, please add them in the Q&A. I'll pick them up and put it to the speakers to answer. So just to give an introduction of the Strategic Innovation Fund, it is a regulated fund that's led by Ofgem in partnership with us, Innovate UK. I guess the purpose is, we're there to accelerate the UK's transition to net zero at the lowest cost to consumers. And again, as most of research agrees that we can harness the power of innovation to kind of reduce the cost of net zero by hundreds of billions, if not more. And also, whilst doing that, it presents a great economic and an industrial strategy opportunity. And we really want to make UK the best place for energy businesses to grow and scale, because we're investing quite a significant amount of money. With that comes a lot of opportunities to really make UK one of the most exciting places in the world to be a test hub for cutting-edge energy system innovation. And I guess in terms of the purpose, there are three things, three key stakeholders: people, you and I, to ensure that our net zero transition is affordable. We all want to do the right thing, but of course we all have limitations in terms of how much we can spend on the transition. So innovation, as an instrument to help us achieve this in an affordable way, and also new products and services. Again, there's a lot of opportunity. There's, the markets are going significant change, and you'll hear from these different projects about, how they're going to bring really new and exciting products to consumers. And of course, in doing that, we can improve the engagement, so it doesn't become something that happens to you, but we are all part of it. We're all part of the journey in concern net zero, and how they become more active participants and almost co-creators in this journey. The next one, of course, is the planet, a critical bit. All of these projects are there to kind of help reduce emissions at a faster rate or meet net zero in a more cost-effective way. And of course, in doing so, there's also a couple of other critical bits, which is energy security. We also want to transition, but then not make the system weaker or less resilient or less adequate. And all of these projects are contributing to that. And finally, is to businesses, as I mentioned, is to support all the different stakeholders that participate in the sector currently, promote growth, because again, this is a big industrial strategy opportunity. And of course, in doing that, attract finance and investment together as well. So that's kind of what the SIF is about. And the next slide, I'll explain a little bit more about the fund. If you can have the next slide, please. Thank you. So it's one of the largest investments, largest innovation funds in Europe. It is £450 million. It's available until the next price controls for a few years. And it's paid for by you and I, all the kind of GB energy consumers through our energy bills. That's how this is capitalized. And therefore, it's quite critical that we see the benefits out of this. And it is designed to help the energy networks and users and the consumers. So everyone who either receives energy via the electricity or gas customers, who can be industrial, commercial, residential. You could be a battery storage or an electrolyzer or, large scale onshore wind, offshore wind developer connecting in. This fund is there to help all of us. And it's a new type of innovation competition process. By new, I guess that the key novel elements are we run an annual challenge. So we speak to hundreds of people across the sector every year and try to come up with what we think are the most timely and critical and impactful challenges that the fund can focus on. And then also the fund is structured in an agile way, which means it starts the discovery where you kind of formulate your problem better, really understand, is there a problem? How big is it? Who is facing the problem? Is it worthwhile being solved? And then you go into alpha, which is, £500,000 in 6 months, which is what we're going to hear from the project today. Have completed their alpha phase, developing new products and optioneering, really. Once we know what the problem is, what are the different ways of solving it? Can we prototype it? And then finally, the next stage is beta, where we go into large scale, I guess, nationally significant demonstration, big scale demonstrators as well. And we're already seeing quite a good potential of benefits. As you can see, kind of low billions in terms of cost savings across these projects, and about 7 kind of millions of tons CO2 equivalent in terms of emission savings in the next about 10 years time. And we've also funded a lot of projects already, more than 200 projects we've funded, dispersed about 136 million pounds, and levering in over 20 million pounds. And also we've reached out to a large population of the organizations, about 300 organizations, and within that, over 70 SMEs that have been supported. So we're quite proud, but we want to do more. And so hopefully over the next few years, we'll improve on these numbers as well. If we can move on to the next slide, please. So yeah, I'll just quickly run through the agenda today. As I said, we have an amazing selection of projects. So we'll be starting with Pride, who are developing a whole systems approach. I think they're looking at heat transport and power and developing a kind of digital planning tool, and also a regional governance structure to kind of support local authorities do more, but also better local area plans that help the networks, that help the local authorities, and help everybody else in between kind of drive that transition. And then we'll be moving on to Inform, who are developing a budget estimation self-service tool, mainly focused on large-scale public sector sites, of which there are a lot in the UK. So think about the big prisons, think about the big kind of army barracks, think about the hospitals. All of them are very complex sites that need decarbonization. But then one of the problems is that when they look to decarbonize, sometimes they get a surprise in terms of how expensive it might be from a connection process. So this project is trying to solve that by creating a self-service tool. So as you're developing a decarbonization plan, you can better understand the cost implications and also help you reduce those costs while doing that. So some interesting use of digital tech there. Then we'll be moving to Powering Wales, which essentially is actually building on a lot of previous work in terms of digital energy systems to create a digital twin of the Welsh energy system to support system planning and kind of flexibility coordination. So we hear from them. And then we'll go to a 10 minutes break and then go to Project Leon, which is, again, in the kind of similar vein, developing a systems approach to better coordinate kind of local flexibility, energy efficiency, and network planning to kind of accelerate that local climate ambition. And then finally, the last two projects we'll be looking at is React, which is trying to address the issues of long lead times and connections and trying to get ahead of the problem by developing a platform that allows early engagement between a renewable energy developer or a project developer and the network, so they can better understand where to connect, how much to wait, cost, etc. And they've used electrolyzers as a use case to test and develop such a platform. And finally, we'll be finishing off on a high with Project Indus, who are developing a novel kind of business model for decarbonization of dispersed industrial sites and commercial businesses. So this is, rather than going kind of one-to-one, they're creating a more collaborative approach so industries can better, faster, and cheaply kind of decarbonize their own assets. So as you can see, a great set of projects, and I'm really excited to hear from them. So as I said, please do put in any questions. This session is recorded, so this will be shared with everyone as well. So you'll have access to anyone who's registered to it, will have access to it. So I think that is probably enough from me. I will now hand over, please, to the Pride team to pick up their presentation. Over to you.
Thanks, Manu. Good afternoon, everyone. My name is Lisa Troszka. I'm Innovation Engineer at National Grid Electricity Distribution. So myself, along with the Pride team, we're quite excited to talk about the learnings that we've gathered as part of our alpha stage and the plans for future. So Pride stands for Planning Regional Infrastructure in the Digital Environment. So if we could move to the next slide, please. I'll just quickly go through the agenda. So I'll provide a project overview of what the aim for Pride Alpha was, and kind of the main streams of work that we've been exploring. Then I'll hand over to Kate to talk about specific work package around local governance structures and the structure that we'll put in place to support local area energy planning. Then Lily will talk us through the digital tool, the digital solution that we are using to support local area energy planning. And Molly will talk through the learnings that will came up out of trials that could potentially support the development of the REST function that's been announced recently, and the next steps as well. Can you move to the next slide, please? Thank you. So this is just a summary slide to say that Pride is funded through SIF, and we've finished off it at the end of March and now busy preparing the beta application. So National Grid electricity distribution is the lead network, but we are very much working in collaboration with the great partners with Combined Authority, Advanced Infrastructure Region, and ESO. And if we move to the next slide, please. Thank you. So Pride Alpha Phase aim was to develop both technical and organizational solutions to integrated planning and coordination of decarbonized heat and transport demand that reduces both cost and the time scale. And as mentioned before, we kind of structured the project around specific themes. So we've recognized that in order to deliver regional decarbonization, the local governance structure really need to be established and the role and responsibilities defined. So that's what Kate will talk about in a second. And then we are proposing a digital solution to support with local area energy planning that is makes it much easier to streamline data sharing between all actors, and specifically for the NGAD, we're hoping that getting the local area energy plan submitted to us through this digital platform will really help us to streamline our forecasting and investment activities. And importantly for Pride, we're gathering all the knowledge and the learnings from different trials to inform and support a regional energy strategic planning process. And with that, I'll hand over to Kate to talk about local governance structures.
Great, thanks, Lisa. We can go to the next slide. So our role at WMCA was really to look at the existing governance structures that we have in place to see if we can kind of bring a level of robust democratic accountability to energy system planning. What do I mean by that? I mean that actually local government is well used to making decisions about place. We do it all the time. So we have statutory responsibilities around spatial planning, for example, around transport planning, and even around kind of the investment decisions that we make on our own assets. But when it comes to energy system planning, often that is done slightly in isolation. If we're honest with ourselves, that it's quite complicated to bring those together. Often the people who are doing the energy system planning speak a slightly different language to local government, and it's very, very hard to bring and align those plans together. But in this new net zero world that we're going to be finding ourselves in, it's more and more important that we do that. If we're going to optimize our decarbonisation pathways, we're going to have to be thinking about whole systems. So how can we utilise the existing channels that we already have so that the energy system can inform, so that we, within local government, can inform the energy system of our plans in a really efficient and streamlined way, but also importantly and iteratively, the energy system plans can inform our plans at the same time. So it needs to be that kind of constant feedback loop. It's very challenging, but we think that there are ways and means of doing that. So we've trialed we thought that there was maybe a gap, and we trialed a new governance trial where we've actually set up 2 new groups. The first one being the one at the bottom, which we're calling Local Area Energy Planning Coordination Group. So that's recognising that there are developing methodologies around local area energy planning, and those local government officers can get together to discuss essentially where we are seeing kind of hotspots in place around development and around potentially infrastructure kind of constraints or opportunities. The second group is actually Net Zero Infrastructure Delivery Panel, and it's equally important. This is where the infrastructure providers themselves, who we know are investing in our area, are coming together to talk in a whole systems way about how do we achieve the decarbonisation targets that we're looking for. So how do we align, the single vectors planning that we've had to date and make sure that we're achieving what we need to for place. So those are the two groups together. And importantly, the LEAP Plus tool, which Lily's going to talk about a bit just after me, is the single point of truth, essentially. It's the system agnostic way that we can share information, share data, make sure we're talking about the same thing, even if we are speaking slightly different languages. Now, energy governance can be a bit dry, essentially. These are kind of colour boxes on a screen, but actually it's pretty critical that we get this right, because if we don't get these informational flows happening easily, securely and credibly, then actually we're going to end up in a situation where we're making predictions in two different spheres that don't come together. And the next slide, which is where we'd like to demonstrate this, essentially. So if we can move on to the next one, we talk about some deep dive work that we've done in very specific places. So we're talking about UK Central here, which happens to be a place within Solihull. And we were utilising kind of existing groups, but really kind of putting a purpose together, which says, if we can get the right key stakeholders around the table and we can bring credible evidence to both the kind of the public and private sector stakeholders and the infrastructure providers, we can come to a consensus view, which is more realistic in terms of kind of how we think the future is going to play out here. And the evidence that we were able to gather was actually that in terms of the impact of those discussions was a pretty significant change from the 2022 distribution future energy scenario, i.e. what was assumed in 2022 to be the rollout of the development on this site, versus the 2023 one, which was after we were able to do this process and we could get together. So actually we were really happy to be able to say that by doing that meaningful engagement, we were able to directly influence the future energy scenario and ultimately the business planning process that goes with that, that looks to prioritise investment going forward to ensure that energy infrastructure then doesn't form a barrier to that development as it takes place. But that was a pretty intensive process that happened over a number of months, with all the key stakeholders coming together and kind of committing to that process. How do we replicate that across a whole region to be able to kind of get the same impact and alignment of realistic goals? Well, that's where we think the LEAP Plus tool comes in, and I'll hand over to Lily to talk a bit more about that.
Thanks very much. If we could go on to the next slide, please. So what Kate has already articulated is the fantastic benefits that we can get from having these sorts of governance structures in place that can be used to inform meaningful change to distribution future energy scenarios or future energy scenarios, and the investment in the network that's there to unlock decarbonisation. And that's what we're trying to digitize and streamline with the LEAP Plus tool. It's a platform that's really there to help bodies like DNOs and potentially also the forthcoming Regional Energy System Planner, the RESP, to build on all that engagement with local authorities that's traditionally been done manually and enable that through a digital tool. It does that by allowing DNO's customers, like local authorities, to use the platform to develop robust decarbonisation plans and share those across these many different stakeholder groups, build on them, iterate and edit. It reduces the time required to build these plans and their cost to deliver, whilst also bringing everyone to operate on fundamentally the same source of truth. We had fantastic engagement in Pride through the participating local authorities, as well as National Grid Distribution, ESO and others. Couldn't fit all of that on a screen. So we've got just one example of a snapshot of some of the typical feedback we got from the local authorities who participated in the black box there at the bottom. And what I think is really key to draw out from this quote is the point being made that finally the council were able to look at data all in one place at a single source of truth and really build up that evidence base that can speed things along because everyone's finally operating off the same place. To make this hopefully a little bit more visual, I'm also going to share my screen and give a quick, very fast fly-through demo of the application. So you should be able to see it now, but this is just a really short taster of some of the tools that local authorities used. So at the core of the platform is a huge number of data sets that we can bring in to help build up this common evidence base, from sociodemographic data sets all the way to fuel poverty, land deprivation, conservation areas, but also crucially a really detailed building stock model of current energy efficiency, current building stock state, and potential for future interventions. So just to give a bit of a snapshot of what that can mean, for example, what you're looking at here is a model of energy efficiency as it currently stands across buildings in one of the participating local authorities. And on top of that, we've used this data to then infer and model the potential for each and every one of the non-domestic and domestic properties in the participating areas to deploy low carbon technologies like air source heat pumps that you can see here. Green buildings are suitable and grey potentially not, as well as make recommendations on the size of these installations. We did that across heat, as you've seen, efficiency, generation as well. In this example, you can see rooftop PV. And we were also able to take this beyond the building to look at things like transport, potential for public zero emission vehicle charging infrastructure, for example. We were able to get some fantastic user research in this phase, and we're really looking forward to bringing in some new data to cover more of the areas that users told us they needed. So gas networks, for example, and heat network zoning are going to be really critical for us in the next phase. Again, very briefly, because we're only able to do a short demo today, I just want to give a bit of an idea as to how we were then able to make this data a bit more interactive. And we had some fantastic contributions from National Grid Distribution as part of this, who enabled us to overlay their own network data sets on top of these models to bring in things like these heat capacity maps you can see, which give an idea of where you've got existing capacity in the network with simple things like interactive red, amber, green statuses that change as users can make changes to the platform. And it was on top of these that we trialed allowing users to do things like build interventions and changes on their building stock. It's really straightforward to do in a digital tool and crucially can be shared between users. So if you want to, you can just simply click and drop assets onto properties, log that with a unique reference number, and even take things off of buildings and connect them to the network like I'm doing with this EV charge point here. This is then data that can be assessed to build up a business case for things like cost and carbon. And it can also ultimately be shared with other users like National Grid Distribution and the RESP to help inform future planning for the energy networks. I'll pass over now to Molly to take us through the rest of the presentation.
Thanks, Lily. If we can just get the slides back up, please. If not, I can pop the up. There we go. Brilliant. So if we could go on to the next slide. Thank you. So I'm just going to kind of wrap up really and bring those two together. So the package of work that Regen had was exploring sort of what the digital solution and the tool, as well as the governance structure, meant for the ongoing development of the new regional energy strategic planners. So these are going to be the regional bodies operated by ESO, soon to be NESO, which is going to think about that high level strategic energy planning in a region. So really thinking about the core function of the RESP in this diagram, which we see as being the lower half. So really about how digital solutions and tools like Leap Plus can support that core function, which is aggregating that critical information from local authorities, from networks, and from regional stakeholders up to a level and in a format that can be kind of understood, processed, interrogated to create those regional energy strategic plans. But also really thinking about how the governance supports the democratic accountability, which is going to be a really important part of those plans as well. So thinking about how the information flow and the decision making that can happen within the governance structure ultimately supports these regional boards and the places of democratic accountability, which we know through this project are really only as strong as the information and the structures that support them. So we spent quite a lot of time really thinking and digging into those information flows and have come up with this structure, which sort of over the next steps and the next part of the project, and as the regional energy strategic planners become more developed, we really want to dive into more and explore in a lot more detail. So they're the three areas of alpha that we explored. If we go on to the next slide, and these are all just wrap up to explain kind of our thinking about the next steps for the project.
Thanks, Molly. Just very quickly, so what we're hoping to do for beta, just building on a really good success of alpha in the governance trial and the tools trial, to expand and deepen our learning even further. And we're very much shaping our beta application around the same three pillars, being that governance, the digital tool, the plus tool, and RESP. So what we're hoping to do is to clearly define roles and responsibilities and the data flows and decision-making process as well, to support and demonstrate how the digital solution could facilitate regional decarbonization, and also through that process demonstrate how RESP could fit into a process and support. So just echoing what Lily was saying, we're really hoping to expand our geographical coverage and show how that process works in different areas, not just what have been trials to date, West Midlands Combined Authority, and make it a truly whole system process involving the gas networks, and also bringing in information about heat network zoning into the process. So very exciting times for us, and with that, we'll welcome any questions.
Brilliant. Thank you so much for the presentation. And I love when a tool demo works on a webinar. And I think you're already getting, a lot of people saying it is great to kind of see the demonstration. They can't wait to use it. So I think that's great validation of the work that you've done. I think just getting into questions, I think there was one, I know it's Lily's kind of written the answer, but I might just for others' benefit, the question, I mean, Lily, if you don't mind kind of responding to it. The question was, is the data and method that went into the building stock model publicly available, or will it be in the future?
Yeah, happy to just come off mute to answer that one. Yes, so we publish the methodologies for all of the modeled data sets that are available in the platform for users. We see that as being really important to help local authorities and their partners understand what model data can and can't be used for. So it's all available in the application.
Brilliant. A few more methods saying it's really impressive, so well done. There's a question from Ian, I think, in the chat around, is there a paper to read in relation to the exciting projects? Maybe someone from the project in terms of how the deliverables will be captured and where it will be available, please.
So I'll answer that one. So there are lots of learnings, as we mentioned. So there are quite a few deliverables which we're currently finalizing. So everything that we could share, which would be pretty much all of the deliverables, would be uploaded on the Smarter Energy portal for visibility and learning sharing.
Perfect. Maybe if there are any SIF colleagues on the call, if we can just put a link to the Smarter Networks portal, maybe into the chat, we can add that in. There's another question from Stefan. Are there plans to index the data sets that are used on an open data catalog?
Lily, I think you would be best placed to answer that one as well.
Yeah, I can jump on that. See, that came from Icebreaker 1. We'd actually like to reach out to you to discuss doing that. So not all of the data sets are indexed on open data portals. Some of them are. It's something we'd like to do. We're aligned with things like Dublin core metadata, and we're discoverable in quite a few places, but we're not on as many as we'd like. So I'll be in touch.
Great. Collaboration and action there. I think those are all the questions. I have a couple of questions. Maybe I'll ask them as maybe others come on. In terms of, I guess, who are the intended users of the tool? I know there's some, I think, local authorities and others who have commented. What's the intended audience? Like, who do you expect would get most out of using this tool?
I can probably come in on that one. So there's two core user groups. One is the DSO. In this phase, there have been two core user groups. One is the DSO, or distribution network operator, who can use it to understand what local authorities are planning to do and help inform things like distribution, future energy scenarios. And the other core group in this phase was the local authority and their delivery partners, who use the tool to build up those plans and understand what they might be able to do. we also explored in this phase, and even more so in hopefully a subsequent phase, we want to look at an additional third group to that, which would be the RESP, who'd need to view a more aggregated form of these plans at obviously a much larger regional level. And we can see potentially very strong benefits to being able to digitize that in an application where you can view things at very, very granular levels, or ultimately aggregate up to much larger regions like a RESP.
Good. And how does one go about using this tool? Is there a license agreement? How does it work if someone wants to access the tool, either now or in the future?
We're a software company, so it's available under a license agreement. Although in the case of Pride, we were really pleased to be able to bring this free at the point of use to all the participating local authorities.
Brilliant. Just one other question on data I had. I'm just checking chat, and if someone wants to add in, so someone has a good repository of data and they've not published it, they want to, is there a way that people can add data layers onto that? How does that work?
Yes, so you can upload data into the application and store it alongside the default layers.
Perfect. Thank you. A question from Rich. Is this also relevant to commercial real estate and private individuals with property?
I'm happy to cover that one. I think we, through the governance structure, we have a number of customer groups where we're trying to kind of bring all that data in, essentially. So absolutely, yes. I sat on what we call a commercial property task force the other day, and the developers are super keen to kind of get involved and bring their data through, because they see grid constraints as one of their primary barriers to development. And that's not the only infrastructure challenge that we have, but it's an example of where actually coming together and working together and aggregating some of that data can actually prove a really kind of powerful and lobbying piece, essentially, to say what infrastructure we need where at the right time for when they're looking to roll their plans out. So we would look to incorporate that through our governance structure and make sure we're kind of aggregating and bringing all together.
Super. Thanks, Kate. And then we have, I think, a question for maybe a couple of questions time for. Just I had one on the governance. I think for all of this to work and the benefits to realize, there's a lot of people that need to come together, coordinated, use it in a certain way, take learnings. I know you've proposed a certain governance process. How much of that does it need to be mandated, regulated, versus how much of it might happen organically, just from your experience?
Yeah, it's a great question. And I think we're fairly uniquely placed in the West Midlands because we've been thinking about this for a long time. How do we set up these groups to have these kind of meaningful conversations and make those informed decisions? But I think it is possible to replicate it. And there are ways, it's not such a complicated structure that we wouldn't be able to kind of flex it for different ways. The different local government setups are in different, in different areas. How much do we need to mandate it? I think there is a real appetite for local government to be more involved. There is an increasing kind of cognizance about the kind of need to align energy, kind of strategic energy planning at a local level. But there does need to be resources behind it. So we've already been seeing kind of local area energy planning kind of come forward in a bit of an ad hoc way. Some people have it, some people don't. It's not a statutory responsibility for any local authority. So it's those that are kind of really looking to kind of prioritize and understand their role in the energy space. I don't know if necessarily the governance structure needs to be mandated, but there definitely needs to be a recognition of the resource kind of intensity that we are looking to alleviate a little bit with the tool, but ultimately there still needs to be ongoing engagement. So making sure that is part of someone's kind of regular day job is a genuinely important kind of thing that we need to be bringing through the system. We're starting to see that with heat network zoning, for example, and we know that there are resources kind of around that zoning space. We would like to see that broaden into a kind of wider energy role for local government.
Super.
And just to build on what Kate has said as well, from sort of the slightly more external perspective, seeing an organisation like the Combined Authority really convene and drive this forward has been really key. And I think obviously structures like this will lend themselves to areas where there are structures existing that kind of pull together that planning and democratic accountability. So combined authorities are really important there. I think one of the next stages of the project, as we expand geographies, is going to be really interesting to kind of see how that pulls together in the absence of a combined authority, and what kind of organizational structures can take on that role where you don't have something like that.
Yeah, agreed. It'd be really interesting to see in a different institutional context how this works. Yeah, I really appreciate that, Molly. I think that's the end of the time. Thank you so much, and thanks for the team for presenting and the tool demonstrations. Yeah, you've already got kind of great feedback from those listening in. I think there's one more question on contacts from the CRE. If maybe someone wants to just add something in the chat, if you don't mind, from the project team. Thank you so much. Right, team. If I can now ask the Inform team to come on video, and I think we can start their presentation.
Yeah, thanks, Manu. Hi, everyone. Tom Stone here from EA Technology, presenting with Craig from Energy Systems Catapult. So quick agenda before we get started. I will give an overview of project concept, what its aims were, what it was trying to achieve. Then Craig will give an update on what we have done at the alpha. I'll then give a demo of the tool, and then Craig will wrap up with some thoughts about where we go next. So if we can have the next slide, please. So the Inform proposition is to effectively build a tool that will help HV connected sites to decarbonize primarily the heating demand. So the existing process for this is kind of roundabout way, and often sites will not consider any implication on the grid connection until quite late into the business planning process. What we've observed is that many sites will get unexpected costs and timelines that prevent that effectively block that business case, either because it costs too much money or the timelines are just too long on it, and the waiting time for obtaining the necessary grid connection is just too long. And for example, funding schemes might expire by the time the grid connection would be available. Our proposed solution using Inform is to build a software tool, effectively an automated self-serve HV connection tool. And the advantage of this approach is that it will provide a free-to-use tool that site developers can use very early in that planning process, such that they're aware of costs and timelines for connections. The tool will also involve some optioneering, by which we mean kind of offering to the site developer various ways that they might consider to reduce either their connection cost or their time to connection. If I hand to Craig, and if we can have the next slide, please.
Thanks, Sam. So we started development of the proof of concept in October. This followed on from a successful discovery phase that was part of the round 2 SIF funding. Round 3 actually. So we started the alpha in October. The first stage of this was site selection. So we had to choose a appropriate part of the network where we could actually test this concept out. We chose the Freeman Hospital in Newcastle. From them, we collected their annual gas and electricity consumption profiles. From this, we developed profiles of peak site energy use under a variety of scenarios, and these were used as a basis to feed into the tool. These were developed using past modelling outputs from the Modern Energy Partners project that Energy Systems Catapult ran. As well as that, we built in benchmarks for energy efficiency savings and costs that fed into the optioneering that Tom just mentioned. These were then passed over to EA Technology, who developed the proof of concept tool using those outputs. And that was combined with network data for the area around the Freeman Hospital, which was supplied by Northern POWERGRID. And there's a little snapshot of what the tool looks like there, but you'll get a better demo of that in a second on the next slide.
Yeah, thanks, Manu. So this is a video demonstration of the tool in action. If you could hit play on that, Manu, and any questions, drop them in the chat. Hopefully there's an audio. Has that audio been cropped out?
The optioneering measures we want to test. We have an input session for our energy profiles. So this can be our underlying electricity profile. It can be if we know our electricity demand for heating, we can put that. Or if we don't, we can check this box and enter our gas profile instead. Now, below that, we have what is currently a grayed out map. And I will talk more about that map when we start an example. So, what you need to do when we are creating a budget estimate for a site is we select the site type. In this instance, we're going to look at Freeman Hospital in Newcastle, and then we enter the site's postcode. As well as that, we put the site's internal area in, and then we look at what engineering measures we're going to include. We are going to include, for this example, LED lighting. We're going to say that it's already been installed to 90% of the building. The smart building controls, we're going to say that's been installed to 50% of the building, leaving 50% for it to be installed further. And we're going to say building fabric upgrades have already been fully completed at the site. We will ignore EVs for now. We're going to say there's no EVs going to connect to this hospital at this stage. And similarly, we're not going to investigate solar or batteries. Now we have uploaded all the basic information about the site, we need to input our profiles. Now to do this, I'm going to show two examples. In the first instance, I'm going to show an example where we don't know our electrified heating demand. So you can see when I check this box saying unknown electrified heating demand, existing gas consumption becomes available as an option. First of all, we're going to input our underlying electricity profile. Now you can do this manually in the boxes as so. However, we recognise this can be a bit tedious. So what we have done is created an upload CSV file option. All that's needed here is a simple CSV file, 48 columns, one row, where each box in that CSV file is simply a number for the half hour from the first half hour of day to the 48th half hour of day. So if I upload this, you can see this pre-populates with numbers from my CSV file all the way through to the end of the day. And in exactly the same method, I can upload the gas profile. And you can see that is also populated throughout the day. Now I can check here that all my inputs are as I wish. And if I'm happy, I press submit to move on. You can see now that the map is ungrayed. On the map is a color-coded cables, red, amber, and green. In this instance, the cables are all red, indicating that a reinforcement is required to the HV network. By the way, these cables are just visible as the HV cables. A reinforcement is required to the network to enable the requested connection. To get an estimate, we first mark the boundaries of our site as so. Once we have done that, we select our existing substation and then press submit. Inform will take a few seconds to think and perform its calculations. And then it will give you some outputs. In this instance, for the specific profile, it will estimate our max additional demand, which in this case is coming out at about 3,438 kVA. And it tells us what the estimated cost for on doing that network reinforcement is, which is for about £449,000 in this instance. It tells us that we've not selected a battery, but it also tells us about our energy efficiency, which you remember we did select. So by installing 10% LED lighting, 50% smart building controls, the tool estimates that the additional demand required from the network is decreased from 3,438 to 3,143 kVA. That is substantial enough decrease to eliminate the need for HV network reinforcement. So therefore, there is no cost associated with upgrading the network. However, there is a cost associated with installing the energy efficiency measures, and that is estimated at about £446,000, which is admittedly a small saving in this instance, but it is cheaper than reinforcing the HV network and has additional benefits for the user, such as ongoing reduced energy costs. Now, you'll remember that I said you can also input it as input your profile as electrical heating already, if you know that. So I will just populate the data again to show that it comes up with the same result, because I have calculated what this should be. In this instance, again, we're using the same energy efficiency measures, no EVs, no solar, no battery. Again, I'll use the upload CSV file to estimate our, to upload our profile. We press submit, go through the same process of selecting the site. And then select where our substation is. We then press submit, inform things for a few seconds, and then it will tell us again what the cost is. Now you'll recognize these numbers. And the reason you recognize these numbers is I've calculated such that the electrical demand and the heating demand, the electrical demand and the gas profile demand are equivalent. But this isn't necessarily the case. This is just a specific example, just to illustrate the fact that you can input your heating data either as a gas profile, if you don't know how it would convert to electrified, or if you already had it estimated what your electric profile will be, if you go down the electrification of heat route, you can input that directly. So there we have it. That is our first example.
Thanks, Manu. If you can have the next slide, please. So I've just put together a kind of plot just to show represent visually what's going on in the tool. So you can see here that it's pulling out the HV conductor limit and the primary transformer limits marked in the grey and yellow lines. And then in there, we've got in the blue dotted line, we have a net profile. So this is the kind of sum of the kind of electricity profile as it is today before we electrify heat, plus the expected electricity demand due to heating. And then that orange profile there is applying the energy efficiency measures that have been input by the user into the tool. And that in this example shows that there's a relatively small decrease in overall energy demand, but that is sufficient in this case to just about pull the net profile with energy efficiency below the HV conductor limit, therefore avoiding the need to dig up the road and replace that HV conductor, which is why you've got your cost saving. I'll pass over to Craig, and if we can have the next slide for our thoughts on where we go next.
Excellent. So it's been really great so far in the alpha to see that we can develop the proof of concept and that it's worked for this site, especially being able to show that there is an example where the optioneering and the implementation of the energy efficiency can actually make a difference in terms of the network connection. But the next phase for this would obviously be rolling this out to a complete network areas to allow any customer to log in to use this. So at the moment, we're preparing a beta bid. So that would be primarily to make this tool work, to sit on the DNO website and then be accessible to people. But we're also looking at what sort of functionality should be included within that. We've already sort of demoed the optioneering, how it can generate the electricity profiles if that's not already known for the electrification route that people might be looking at. We've done some stakeholder engagement through both the discovery and the alpha, so we've got really good input from various types of stakeholder into what things would be priorities for them. And there's a few examples here that we're currently exploring if these are things that we would be able to look at in a beta phase, or if there are potentially opportunities for future development beyond that. So things like improving how the energy efficiency optioneering works and the battery storage algorithms to better estimate the impact of peak demand. Like Tom mentioned there, while the tool is currently showing the cost of the energy efficiency measures, it would be great to also show what the cost benefits are as well. Allowing the user to manually select the heating technology they expect to use. So whether they think they'll use an air source heat pump or direct electric would have a different impact on the peak demand. Other optioneering, so thinking about flexible connections and thermal storage and the impact they could have. Allowing users to look at multiple options in parallel to allow more optimization of the ideal combination of the optioneering measures. Timelines to understand an estimate of the time to actually get the connection, and then functionality like account creation, savings estimates, and export functionality. So a lot of things that we could develop into this. So really we'll be looking at what the key things will be to get this in the hands of people, and then where we go from there. So great. Yeah, thanks very much for listening, everyone, and happy to take any questions.
Thank you. Thanks, Tom. Thanks, Greg, for the presentation. And again, like really good tool demonstration. Again, you're getting some good feedback from people who've just been seeing this. Just gonna look at the chat. I don't think we've got any questions yet, but I've got a couple, so I'll kick things off, and then hopefully others will kind of feed in. You just type in fine. I'll give him a few seconds. So who can use the tool at the moment? Is it just public sector sites or any kind of commercial industrial building within the catchment area of the network?
At the moment, it's just the Freeman Hospital because it's a proof of concept. That's kind of all we could include within the alpha phase. We are envisaging to roll it out to the entirety of Northern POWERGRID's network license areas at a future phase, which would mean any H3 site, any site with a H3 connection would be able to use the tool.
Cool, thank you. And I think there's like a collaboration request from Ian, and maybe I'll let you or Craig kind of message him directly on, can we look at an API and explore the project together? So there might be some opportunities for you to kind of look at collaborations for beta phase. I'll let you guys comment back. The other question I had was, how up to date will this tool be? Like, does it get updated as and when like new developments and grid works takes place? Like, how dynamic is the data on the system?
Yeah, so we'll be looking at having a kind of automated data feed from Northern POWERGRID's data source, which will get updated as Northern POWERGRID update their network data. So the idea being that, if they go and make a reinforcement, then the asset ratings will get updated to reflect for a fact that reinforcement has been made. Similarly, if they have kind of connections come in, it will link to that and say, okay, we've got this additional demand, therefore we've got less room to play with, and all that will be done autonomously from Northern POWERGRID's pulling in from Northern POWERGRID's data sources.
Good. The other one was around just heat networks. Are heat networks modeled as part of the tool?
They are not at the moment. We are open to including other heating vectors, should we say? at future phases, particularly any that have an impact on the electricity network, which heat networks for sure will. So yes, not at the moment, but maybe in the future.
Super. Yeah, the other one was just because you said optioneering, so it tells you that if you had flexibility of storage or you did energy efficiency measures, does it then like from your research, how do the end users use that information? Is that, do they have to go find their own retrofit developers? Do you signpost them to people to finance, or is that we kind of assume that they know what to do about that next?
So I think we'll definitely want to consider what sort of signposting there is beyond this. So clearly at this stage, it's a budget estimator and clearly a quite high level one based on the information that they enter. But the idea would be to signpost them towards whatever guidance or people within the area they can speak to that can help develop things a bit further. Just to make sure they this is the first indication of what they might want to consider. So it gives them some knowledge going into discussions they would have with people. Oh, I want to explore this because I'm aware from the tool that these are the sorts of implications that might support getting the project implemented faster. So yeah, that's definitely something we'll be looking at for the betas, what sort of signposting we give.
Okay. And I guess from the couple of the other presentations that we've had, some similar lines in terms of the kind of networks understanding what's going on bottom up, but the other players also understanding what the networks are doing that enables some kind of more effective transition. With that view, I mean, is there a plan for the networks to potentially use some of the data that's coming in to go, oh, actually, you know what, I've seen 8 kind of speculative analysis on this tool. Is that a hotspot of area where I think there's going to be some reinforcement needed? Is there a communication the other way where they follow up perhaps or have a conversation, or they think about network planning in the context of what people have been analyzing?
So just checking, kind of understanding the question here. Like when you say feedback the other way, is that back to the network operator?
Yeah, so yeah, exactly. If in the beta phase, you're able to do it over a bigger patch, and I can see a clustering of analysis happening in a certain area, and everyone wants to electrify that. That of course starts to tell the network something which otherwise they would not know, that someone is planning to electrify, 200 megawatts of demand order. Yeah, so that's
yeah. So this is definitely something we are considering. We said there that it will be any HV network site. Obviously, it will be available to the DNO itself as well to kind of have a see of what people are doing. The question about how we kind of fold that into network planning and improving that planning process is one under active consideration at the moment, and we're actually running a discovery project called SAND that is looking further into that question. And what we're trying to work out with that discovery project is how we do all of this kind of connections and planning in the most effective and efficient way, but also making sure that it's still as user-friendly and intuitive as possible.
brilliant. Maybe Tom, if you got a second, just maybe paste the link to that project in the chat so that others are interested, they can look into it. So I think that's yeah, thank you so much for both of you for kind of presenting and demonstrating the tool as well. Again, some really good feedback from people listening in, and yeah, good luck with the next steps. Thank you so much.
Thanks, Manu.
Thank you. So next we'll be moving to the Powering Wales Renewably project for presentation. So maybe if I can ask the project team to please come on video and start the presentation.
Hi, I assume you can see me?
Yes,
Can you hear me?
I hear you clearly.
Great. Hi everyone, I'm Joshua Visser, Senior Innovation Manager at the ESO, and I'm happy to introduce the Powering Wales Renewably project. With me is Rich Hampshire and Simon Brown from our project partners, CGI. Next slide, please. So what is this project? This project aims to support the ambitious Welsh and wider GB decarbonisation targets. It will help to enable better connections of future renewable generation and other new flexible sources of supply and demand. It's a solution that can be replicated to other regions of GB to ensure safe, reliable operation of the net zero power system by 2035. Building upon existing work, the project will do this through delivery of the first digital twin model of the Welsh energy system, the first whole system representation of flexibility requirements, DER availability and dispatch, and the first top-down and bottom-up comparison of local area energy plans, network development plans, and the connection queue for alignment and tracking. Next slide, please. Powering Wales Renewably aims to develop a whole system approach to energy planning. It aims to drive greater digitalisation of the energy system, reduce costs to deliver a net zero power system by optimising planning, investment, and operational decisions. The project is engaging closely with stakeholders across the value chain, ensuring future end users' needs are being met. It will provide longer-term strategic solutions for Welsh energy system transition challenges and provide use cases that address visibility of the foundational energy system network status, coordination of flexible resources, and integrated energy system planning. I'll hand over now to Rich and Simon at CGI to take you through more detail of how we will deliver these outcomes, starting with the rationale for doing this project now.
That's great. Thank you, Josh. It's 2 years since Powering Wales Renewably was conceived and pitched as an idea for SIF Round 2. The concept built upon previous innovation projects that had delivered intelligent digital models for electricity networks. The objective was to prove the additional value of connecting these digital models of the individual distribution and transmission networks, and to create a digital twin at a national scale by delivering a whole system digital twin of the electricity infrastructure across Wales. Through Alpha, we've been able to access and include gas asset data as well, and extended the ambition to establish a whole energy system twin. The project was conceived around delivering the foundations of a public interest digital asset, or digital common. Such a digital asset addresses specific use cases and solves challenges identified by different system actors, partners on this project. These include helping to achieve the Welsh Government's ambitious decarbonisation plans by identifying areas where there is capacity headroom to connect renewable generation or decarbonise demand. Additionally, by integrating further data sets, we've been able to identify where flexible assets are connected to the networks. Through the discovery and alpha phases of Powering Wales Renewably, the policy and regulatory landscape has also increasingly focused on these same challenges. Last August, the Electricity Networks Commissioner, Nick Windsor, published the recommendations on accelerating electricity transmission network deployment, with the stated ambition to halve the timescale for building strategic transmission, bringing the timescale down to 7 years. The government responded in November with the Transmission Access Action Plan, which included the role of the Future System Operator, soon to be NESO, in producing a strategic spatial energy plan and centralised strategic network plans. With the publication of the decision on the FSO's framework for centralised strategic network plans, the requirements of these new responsibilities for NESO have further been fleshed out. By delivering the ability to undertake top-down and bottom-up comparison of these strategic plans, Powering Wales Renewably will support delivery of the energy transition in Wales. Similarly, Ofgem's call for input on the future of distributed flexibility and ongoing work on a flexibility digital infrastructure can be informed by what we're doing on Powering Wales Renewably. Next slide, please. As I've outlined, Powering Wales Renewably has been structured around use cases, primarily 3 use cases that address the real-world challenges of the energy transition. Today's demonstration of the solution will show how, through the collaboration of the project partners, During the alpha phase, we've been able to share and access the data necessary to deliver the proof of concept for the foundational connected digital model of the whole distribution and transmission system across Wales. This foundational model can be built upon to support project partners and wider system stakeholders in identifying where it is possible to connect renewable generation and decarbonise demand in a timely and economic way. Through the inclusion of flexible asset data sets, Powering Wales Renewably solution will be able to support the coordination of flexibility requirements between the future NESO and the DSOs, and in doing so enable Welsh integrated energy transition planning to achieve the net zero ambition. With that, I'd like to hand over to Simon.
Thanks, Rich. Next slide, please. The focus on digitalisation of the energy system and the work we have done with DNOs on creating intelligent models of the electricity network were the inspiration for the project. ESO, NGET, and the Welsh Government shared our vision for exploring the future potential of a large-scale digital twin of the energy system. Aligned with the Welsh Government's ambitious net zero plans, we focused on accelerating the benefits that can be achieved from the first energy twin at a national scale. This will address not only the technical, but societal and local community requirements to deliver on these key strategic goals. The vision formed prior to discovery has been maintained and enhanced, and the relevance and timeliness of the PWR vision has only increased from the first submission. During discovery, we focused on the core barriers to net zero through the project use cases. And whilst the potential for a digital twin of the energy system can have a massive scope, we as a project have remained focused on these barriers in the 3 use cases that we have chosen. We welcomed SPEN and SSEN as partners through the alpha phase. We engaged with a wide range of stakeholders groups to get multiple perspectives on the use case challenges, from community energy groups, developers, rural energy consultants through to the Welsh Government and the many departments and experts within our broad utility partners. We've conducted extensive stakeholder engagement workshops and have clear line of sight from the problems through to the benefits that PWR looks to address for each use case. We have also engaged with other SIF projects such as PRIDE and explored the potential for PWR to support strategic planning with ESO and how the alignment of these plans and subsequent dissemination can be supported through a platform such as this. We are pleased to have a project sponsor in Bridget Hartley on the project, who is responsible for the creation of the regional energy system plans for the ESO. To support these workshops, we created a digital pathfinder of the foundation use case during the alpha phase. This has been crucial in shaping the vision and for stakeholder alignment and has contributed to the increased momentum the project continues to gather through alpha. We have an opportunity in beta to be a real game changer for data, digitalisation and the Welsh net zero plans. We have further increased the partners to bring in National Gas and Wales and West Utilities to move the digital twin from that whole electricity system twin through to a whole energy system twin. We look to engage across all stakeholder groups to build communities around Powering Wales, to bring together a wide range of partners and stakeholders to collaborate around a common platform and accelerate the vision as defined by the Energy Data Task Force for the role open data plays in addressing net zero. During alpha, we've used a benefit-led development of the original vision and use cases as the barriers identified have been reported in subsequent SIF challenges and government papers. When we started, who would have thought that the connection queue would be referenced by the Prime Minister in Prime Minister questions and is a topic on the BBC News regularly. Next slide, please. So what have we learned from alpha is the importance of the whole system, partly in response to the regional energy system plans, but also an identification of the value in bringing together a cross-vector twin of Wales. Also, through discussions, the opportunity to address for local energy schemes to offset curtailment through increased demand, not just low carbon generation, has shaped some of our thinking and the applications to be developed as we address the use cases. And this will provide real economic and social value to the people of Wales. Finally, through building the Pathfinder, we have real practical experience of integrating open data sets with industry data. The techniques, learning and insight from bringing together available data sets is useful not only for Powering Wales, but also for the wider industry as we look to feed back to the relevant stakeholders on interoperability. I would now like to share with you a video of what we have built so far for the foundation use case. This Pathfinder has been built using static data and published open data from a number of sources. In early beta, we will put in place the necessary infrastructure to support regular refreshes of the twin and build the tools required to deliver the benefits as identified in our use case solutions. This is so much more than just a map. So, I'll now play video.
Having a holistic view of energy networks is key to delivering the most efficient and effective system to meet the current and future needs of a low-carbon society. A digital asset that can connect data from many sources to provide this holistic view will enable people to be involved in the energy system, so it truly delivers in the public interest. This is a priority for the Welsh Government in ensuring a fair transition.
The soon-to-be-formed National Energy System Operator will have additional responsibilities relating to national and regional energy planning, with Wales being designated as one of the new Regional Energy Strategic Planning regions. For Wales, the Regional Energy Strategic Planner will ensure appropriate accountability and effective coordination at sub-national level, ensuring that regional planning is cross-vector, considers local priorities, and is coherent with national energy planning. We are the lead partner for Powering Wales Renewably project and fully value the opportunity to work with our stakeholders to collaboratively develop innovative solutions to the challenges identified and enable realization of Wales' energy plans.
Thank you. Can we have the slides back, please? And can we have the next slide, please? So to summarize, this ambitious project is a pathfinder and accelerator to provide the step change in releasing value for open data, interoperable energy system, stakeholder engagement in net zero, and strategic system planning, helping Wales accelerate net zero targets and produce a digital twin that can be a template for a wider rollout across GB. I'd like to hand you over to Joshua again, please. Thank you.
Next slide, please. Thanks, Simon. So we've taken you through the rationale for doing the project now, how it will help to meet industry decarbonisation and whole energy system ambitions, and what is actually being delivered. We've also heard feedback from a couple of key stakeholders about the benefits they see from the Powering Wales Renewably project. So what are the next steps for Powering Wales? We're currently finalising our application for the project's beta phase. We will continue disseminating learnings we have from the Alpha, including to a cross-sector digital twin community at the upcoming Gemini call on the 14th of May. And we're keen to continue widening the collaboration we do for the beta phase. So if you are interested in more closely engaging in this project, please reach out to us. Aside from that, thank you for your time, and we welcome any questions you might have.
Thank you, Joshua and team, for the presentation. Just waiting to see if there are any questions yet. I can't see any questions yet. Maybe I'll start off with mine and then let's see what comes on. So the first one, I was just quite interested to understand the scope of the flexibility coordination model. If you can just elaborate on exactly what that's intended to do and where the data is coming from.
I'll pass over to Simon for that one.
Yeah, so I think it's about the flexibility coordination across the whole region, Manu. So what we've got within Powering Wales is an intelligent network model. So we can see the characteristics of the electricity network, and therefore by coordinating the flexibility that's being actioned across the whole of the region, we can coordinate between transmission and distribution and any other vendors, any other actors, to make sure that it is coordinated correctly and it's not oversold or undersold across Wales. I don't know if you want to add anything to that, Rich.
When you say, helps if we can find the unmute button. No, Si, I think you've covered it well.
And just from my understanding, when you say flexibility, what are we exactly talking about? Just battery storage or demand-side flexibility, EVs, thermal storage?
Everything, to be honest, on the flexibility. That will be traded for flexibility response money. We're looking to speak to the different platforms and make sure that there's visibility across all of those platforms through the Powering Wales platform.
Okay. And so where does the data, how do you get the data of how much flexibility and what kind of flexibility is there?
So it's a good question. We've got the hooks within the model to support those data items and to bring that together. We've had initial discussions with a number of flexibility platform providers as part of the project, and we'd look to bring that in during the beta phase.
Yeah, thank you. And I guess the other question is kind of linked, but how does the whole model deal with uncertainty, I guess, in terms of as you learn more about social acceptance of new technology or just new technology, market changes, how are you kind of built that in of, we're in a period of big change, how is it getting reflected in the framework and the model?
So the actual data model is built from something that is provided by the network companies. So we get a regular refresh of the as-built network, and that's the base foundation model, which we're looking to do as the first phase of beta and build that up. And therefore you'll have a current view of what is currently built. And then what we need to do then is look at some of the future pieces. That's where the regional planning and the strategic planning elements come into it. And the vision for Powering Wales is to be able to see all that in one place for multiple stakeholders as well. So.
Okay. And so where will this be hosted, and who will kind of maintain and manage this overall model, and who can access it?
Yeah, so I don't know if you want to take this one, Josh, but it's a ESO-led project.
Yeah.
So what we're looking to build during beta, and as part of the security and the user model that we've done some work on during the alpha, is to make sure that data sharing and what access to data is configured and is made available to people that need to know and can know, and everyone's agreed to. So we see a number of different views upon the data and a security model around that to make sure that access is delivered to the right people. So the strategic planning team within the ESO may want to see one set of more detailed data, whereas a developer would probably have access to a smaller subset of that data for what they need to do. So it's about providing the right data to the right people at the right time.
Yeah, like someone says, we see this as an industry tool. Where it's actually going to be sitting is something which we're discussing at the moment as part of the beta application. The idea is ideally it will be ESO hosted, but we're still ironing out exactly how that will work.
Okay, thanks. There's one question that's come in around, I guess, coordination with other relevant activities. The question is, there's a few projects going on around developing digital twins of the power system. I think they've called out that SSE is doing one called Ensign at various levels. So to what degree are the projects interacting with each other? I guess maybe from your experience, how have you interacted with other digital twin projects?
Yeah, so this is a use case for the Virtual Energy System program. So this is really a pilot of building a digital twin, which will adhere to the framework, the common framework principles of the Virtual Energy System, which will be an integrated network of digital twins. So all digital twins will be able to talk to each other. That's how we're designing it, and that's how we're working with the Virtual Energy System program to make sure that as digital twins are being built across the system, they're all being built in a way that they can be interoperable.
Great. And I think that there's also talking about like whole system. So will kind of gas infrastructure and hydrogen be part of the model as well?
Correct, Manu. I could be wrong, but I think it's SPEN doing Enzyme, not SSEN. And Scottish Power are a partner on the project as well. So
yeah. And just on the whole systems one, Simon, do you want to pick up the question?
yeah, so what was the question, Manu? Sorry, I was just
about hydrogen and gas data.
Yes, so we've been speaking to Wales and West and National Gas, and they've agreed to come on board for the beta, but that's quite sort of late breaking news within the alpha phase, so it's just towards the end of the alpha. So yes, bringing in the gas data is something that we're looking to do within the beta. And I think it's important as well when you look at the local area energy plans, which are both gas and electricity, we need to bring that through and take it out to the wider scale for the whole region. So.
Good. And is this then an instrument to support the kind of national system operator who might look across multiple vectors as well? Is there an ambition for the tool to support the function?
That is that ambition, yeah.
Great. I don't think there are any more, so let me just check the chat as well. Yeah, I don't think there are any more questions. Yeah, thank you so much for coming and presenting. Appreciate you.
Thanks very much. Cheers.
Thank you.
Thanks, everyone.
Thank you. So I think we're going to move into a break for about 15 minutes. And so we'll come. I think we're moving on to the second half of the session. So if I can please invite Project Leon to come on.
All right, Manny, how you doing?
Very good, thanks. Hey, Frank.
Good, good. Just tell me when you're ready. You want me to start?
Yeah, all yours.
Okay, thank you. Thank you. Good afternoon. Thanks very much for giving us the opportunity to share the outcomes from our Round 2 Alpha project, Project Leon, our local Energy Oxfordshire neighbourhoods. I'm joined on the call by two of my project partners, Barbara Hammond from Low Carbon Hub and Timur from Baringa, who helped us with this EBA. We can see the other partners on the logos along the bottom there. So if you can move on to the next slide, please, Manu. So what the project's about is about trying to drive, in common with some of the other projects mentioned today, it's about coordination in governments and driving the energy transition. But what sets Leon apart is really focusing on the grid edge. And what do we mean by the grid edge? From our DFES scenarios, just in our Southern Electric Power Distribution region alone in central Southern England, we're anticipating 1.5 million electric vehicles and over 500,000 heat pumps to want to connect to our network by 2030. And that's going to appear across 900 or so primary substation sites, 60,000 or so secondary substation sites, and north of 300,000 LV networks. So you can see the need for coordination at that massively diverse scale is really, really important. And that's what Project Leon's, one of the key outcomes of Project Leon, is to drive that coordination and make it happen at the grid edge. And what we're looking to do is take advantage of communities' readiness and exploit that and understand it better, and then utilise that to bring the bring less engaged and less well-equipped communities up to speed. And this efficiency and coordination gives a massive opportunity to coordinate with our own investment programme and really drive some efficiency in that network upgrade plans. Just coordination at a grid edge is vital to provide the right pace at the right place and the right pathway for communities to achieve the full transmission. So if we can move to the next slide, please, and I'll hand across to Barbara.
Thanks, Frank. So as Frank says, accelerating decarbonisation of major energy demands means really deep action, embedded action at the grid edge, the high voltage and low voltage networks. On the Boston box that we show here, along the x-axis, we say that we need market scale, but we also need, to meet full transition, the y-axis, which is geographic density. To get to full transition at the grid edge, which is the green square, we need both of those things: mass market scale of smart households and businesses, and dense provision of those at the LV and HV level. If that's not coordinated with the DNO, so that the DNO can touch each piece of their distribution networks once between now and 2050 in a planned, orderly, and therefore cost-efficient way, we get grid edge anarchy, as we call it, which is our purple box. This is where we think that policy is tending now. Doing nothing to plan and organise this will mean that consumers are unhappy with the DNO because they can't get connections, and the DNO will be pushed into unplanned and costly reinforcements without being able to plan the skills and supply chain to provide those reliably. Innovation trials, on the other hand, tend to favour nice examples, our yellow box, because we need to trial that geographic density, without which we don't get full transition. But the business models that those trials demonstrate are very hard to commercialise. The smart community energy schemes are difficult to demonstrate and scale without major changes in policy. For example, primacy rules for flex tariffs. For example, direct energy trading from distribution or LV scale renewables. They also need specific technical innovation around the provision of a digital spine that can coordinate demand to provide HV and LV peak management, and also manage the matching of demand and supply with local renewable energy generation. So full transition means being able to coordinate market scaling so that it can provide geographic density, whilst developing smart community energy scheme models that can provide reliable peak management to the DNO behind each secondary substation. Handing back to Frank. Next slide, please.
Thank you. So where are we today? The challenge we got today is getting that grid capacity at the grid edge, or getting that network capacity at the grid edge. Our local authority partners are developing their local area energy plans. How they'll actually result in implementation is yet to be seen, and we're already seeing some individuals making the transition in an uncoordinated way. So that's there is some work ongoing to them. We already heard today about other projects that are looking at the RASP, helping develop local area energy plans and the like. But what we're looking to do is actually turn those into reality and actually make sure they get delivered. We're also seeing some of that grid edge anarchy, as Barbara described it, and a symptom of that is this connection queues, which are all too visible at the moment. So what Leo's trying to do is take advantage of some of the opportunities we see as being there, and that's to improve the network visibility at the grid edge, really drive DNO's secondary investment programs so we can actually upgrade the right network at the right time to make sure the capacity is there. We're looking to develop some new flexible options to help us better manage demands on a network, which is another option for managing that investment process. Really try to drive that coordination at ground level to deliver and actually close this delivery gap, and hopefully give a bit of a roadmap for homes and businesses to let them achieve their own decarbonisation route, and actually open up further opportunities for communities. So Leon's really looking to help close the delivery gap to allow us to progress to that full transition. If could you just hand back to Barbara, please. Next slide.
Oh, is that the next slide, or is, sorry, that's not quite in the right order? Thank you. So this is the system we're proposing in Lyon. Local area energy planning, as we currently know it, can provide strategic coordination at the extra high voltage level and into the regional scale. And it can do that also for smart local energy schemes, as we've seen in other presentations, that coordinate industrial scale demand and generation. But we've identified a delivery gap between the local area energy plans at the regional scale and achieving decarbonisation on the ground at the grid edge where we all live and work. The combination of the grid edge coordinator and the digital LEAP platform fills that delivery gap. The grid edge coordinator provides the coordination needed to see projects at the LV and HV level through to delivery. It provides energy system expertise at the grid edge and mediates the relationship between communities, local authorities, and the DNO in a trusted way. And it can feed back insights from the LV, HV level back to the regional level. But to do that job, the development of the digital LEAP platform is a critical component if we're going to achieve system efficiency. The platforms need to enable multi-level local area energy planning, be updated in real time when there's new system data and as projects progress, share data appropriately with different users, including the grid edge coordinator and community representatives, and reduce the cost of creating local area energy plans at any level in order that valuable resources can be focused on engagement and delivery. Next slide, please. Thank you. We have developed this model working up from the experience of operating in depth with places across Oxfordshire. And these are three examples of those in-depth community-based projects. On Osney Island, we worked with SSEN to understand the LV network behind a single secondary substation. And we found that there was a lot of knowledge to gather and data to understand that wasn't really being coordinated at that point. In Ensham, we produced a single community-led neighbourhood local area energy plan for a primary substation area to find out what planning would look like at that scale and how to involve the community and community members properly so that they can take action. And at Rose Hill, we've been gaining learning from the experience of market-led scaling of heat pump delivery behind two secondary substations. And we think what it boils down to is the four boxes at the bottom of the slide. We need the dynamic digital leap that can work from the regional scale right down to the granularity required on the low voltage network. We need that coordination between the local area energy plan, the supply chain, the community, and the building owner, so that the mass market can develop. The mass market needs to provide smart retrofit in a package rather than just heat pumps or just EV chargers or just solar or just batteries. And these smart retrofits behind the individual meter need to be strategically coordinated in their delivery so that we can get the density of smart retrofits required that can operate in front of the meter as smart community energy schemes to provide reliable peak management right down to secondary substation level. I'll hand over to Timur for the economic benefits. Next slide.
Energy Systems Catapult previously estimated that the fully coordinated local area energy planning implementation to be worth of 252 billion. Leon solutions are expected to unlock proportion of it. And in the alpha phase, we have estimated that Leon is to be worth of 21.4 billion nationally between 2025 and 2050, which also includes environmental and social values plus network savings. The main drivers behind these values are twofold. First is the strategic coordination, which delivers the value from more efficient network investment and network planning, plus greater and quicker uptake of LCTs at the distribution level. Second is the tactical coordination for self-consumption and peak management at the community level, which then delivers benefits directly to the households and businesses. And these benefits will be tracked and validated during our beta journey. Next slide, please.
Thanks, Timur. So Leon Beta is about setting up and demonstrating the grid edge coordination we have identified and described in Discovery and Alpha. We'll continue to use our lean ecosystems transition approach to developing use cases as it brings together the right people in the right place at the right time to learn rapidly and to adapt to complex systemic changes that we can then test in the real world. The process integrates the different work packages across Leon Beta to ensure the successful delivery of the program, even when we face large-scale changes, as we inevitably will, in the broader environment. So during Beta, we will develop the Lensa digital mapping platform so that it can support and enable dynamic energy and network planning from grid supply point to LV feeder. That mapping platform is already in place and being used, but it needs to develop, very much along the lines of the PRIDE model seen earlier. We need to use the platform to take the production of neighbourhood local area energy plans that we call CAP Zeros from a single demonstrator to a business as usual product that can cover all 63 primary substation areas in Oxfordshire, and that can then be scaled into the UKPN and NGED areas. Those networks are already collaborating on the development of the Lensa platform, so that we can demonstrate how the grid edge coordinator role can enable the scaling of the smart retrofit market within DNO plans for HV and LV investment. And we can identify the range of potential smart community energy scheme business models and model their impact on peak management behind the substation meter. We will scale the approach from the single places we have started with to 2 of our 5 Tier 2 authorities in Oxfordshire with whom we're already working closely in established partnerships, and then to all 63 primaries throughout our 5 Tier 2 authorities. 12 of those primaries are in the UKPN and NGED networks, which are already collaborating with SSEN on the Lensa digital platform. Next slide, please. But an affordable system relies on the LEAP digital platform, which enables significant reductions in the cost of developing a neighbourhood LEAP. Our Ensham pilot cost around £116,000 to deliver. Amazingly enough, or coincidentally, this is almost identical to the cost of a contract awarded this year to a major consultancy to deliver another primary substation LEAP in Oxfordshire. Our alpha analysis shows that we can reduce the cost in the next innovation cycle in Leon Beta Phase 1 by more than half, using SSEN's Lensa platform for local area energy planning to do the majority of the energy system data analysis. We forecast that in the next innovation cycle, this can be more than halved again, with new LEAP digital functionality and operational efficiency. Our target is to get the cost down to under £10,000 for a new plan from scratch, once we also incorporate economies of scale. Next slide, please. And these are the places we have lined up to work with us on developing these efficiencies through Phase 1 of Beta. We've already completed the Ensham primary substation area neighbourhood LEAP, and we'll use that to develop the model for grid edge coordination. We will develop the functionality of the Lensa digital platform in Phase 1 using the places denoted by the yellow hexagons. The green hexagons show places we may bring into Phase 1 that offer different LEAP use cases. We will use the resulting neighbourhood LEAPs and the digital platform to develop a reliable method for rolling out area-wide smart retrofit projects at feeder and secondary scales. And we'll trial modeling for smart community energy scheme use cases where smart retrofitted buildings and local generation match demand with supply and flex use to the needs of peak management at the secondary substation. Next slide, please. We'll start scaling the Leon approach in phase 2 to the tier 2 local authorities we are already working with closely on the Ensham and Charlbury projects, that's West Oxfordshire District Council, and the Osney and Rose Hill projects, that's Oxford City Council. Each of those districts has around 14 primary substations in it, with around 120 secondary substations associated with each primary. Next slide, please. In phases 3 and 4 of Leon, we expect to scale to business as usual across Oxfordshire and beyond. As we've said, we have 3 DNOs operating in Oxfordshire, SSEN, UKPN and NGED, and our local LEAP governance already includes them. So we would expect to be able to work with them on rollout. Oxford City also works with a network of fast growth cities throughout these network areas and is already in discussions with Cambridgeshire on a joint collaborative approach. There is also the Oxford to Cambridge ARC grouping of local authorities by which to organise rollout. Finally, on the national scale, we are aware of key projects in Manchester, the West Midlands and the North East, where collaboration could provide a fruitful route to rollout. I'll hand back to Frank at that point. Next slide, please.
Yeah, just to finish off presentation, as I said, it's about accelerating decarbonisation at Grid Edge, and to make that happen, we think we need some new tools: digital leap platform, the Grid Edge coordination role, and some suitable governance to support it. So we're really excited about taking this forward, and think we've got a very, very worthwhile project. So happy for any questions now.
Thank you, Frank, team, for the presentation. Yeah, really interesting. In terms of questions, I think we've had one. Barbara, Frank, are you able to explain a little bit more about the work that the Grid Edge coordinator will undertake and the value add that it will produce? Leon is clearly a flagship example of how this can be delivered locally, but with far-reaching synergy for other areas to adopt. So, yeah, if you can elaborate on the Grid Edge coordinator, please.
Do you want to go first, Barbara, or do you want me to start?
You start, Frank, and I'll follow.
Thank you. I mean, it's a number of different stages, right? We've identified a kind of evolution of this Grid Edge coordination role from the kind of really early inception and creation of these Cap Zero plans with communities and working with them to, depending on the nature of the community, some are you know, well informed but low resource, or they've got better resource but not haven't got the so organisations or various different communities which you've categorised, which Barbara will maybe explain a bit more clearly than I just did. But it's about the creation of that plan, this Cap Zero as we've called it, and then the evolution of that, helping with the commercial, the delivery of it, and sort of matchmaking and spotting opportunities to work together, and then the stewardship of any community energy scheme, which then goes on beyond that for as long as it's needed. So it's about trying to steer it, unblock some of the many blockers that will be in the way, and also clear away some of the fog which inevitably exists around about some of these issues, to try and demystify it and make it a bit less scary for people to become involved in, and actually give them the confidence that they're not on the journey on their own. Barbara, I don't know if you want to add any more to that there.
Yeah, I think it's really about that ability to coordinate between the system, the technologies and the business cases for those, and the people. And I think we cannot underestimate the amount that people at the Grid Edge don't know about the energy system and what they need to do. So the Grid Edge coordinator is about making sure that the community can be ready to do things that the network can allow them to do, that are going to be of benefit to the household or the business owner, at the same time as being of use to the network. And that's where we get the efficiencies that deliver the economic benefits we're talking about. What we're all about is trying to ensure that we make the transition to a zero carbon Grid Edge with mainly electric heat and transport, in a way that doesn't mean that in tripling or hopefully just doubling our energy demand, or electricity demand, we don't then have to increase the size of the distribution network by 4 times at the HV and the LV levels, and frustrate a lot of people in the process, because they won't be able to get their EVs and their chargers in. So it's really about that coordination between the people and the kit that we're about.
Thank you.
In terms of the value, sorry, I was going to say, Manu, in
sorry,
terms of the
Bangor.
value add, just for kind of quite a selfish DNO perspective, what this better visibility and better certainty of what's happening at the grid edge gives us is an ability to plan that reinforcement program across thousands of assets. So our DFES scenario is suggesting we've got, you know, thousands of transformers which may need to be upgraded in any 1 year. Managing that program work efficiently and effectively is really challenging, but getting better foresight of what's coming really allows us to drive efficiency in that program with the supply chain, our contractors, and minimize impact on our customers as we go through that. So that's where we see a lot of the value add coming from this.
Yeah, that's good. And I think we have a couple more minutes. So one other question that I had was, of course, there's a lot of interlinked elements in this project. And as you said, I think some of the bits that are happening, so people are doing retrofits, people are doing flexibility, and there's some level of coordination and sequencing of those that we need to do. And then I think, Frank, as you said, there are some new things that we need to do as well. We need some better coordination of existing things, and we need some new things. Maybe can you just explain a little bit about, in your project, what is that enhanced coordination? What are some new bits that you're proposing?
So
I think everyone's understanding.
Yeah, if I can just start, Manu. So if I think on the slide which Barbara shared, you can see the range of different communities we've got engagement with across Oxfordshire. I think there's about 10 to start with. We've probably got another list who are very strong potential to work with us. They're all at different points in that journey. Some have barely started, others are actually, you know, well on the way. They've got some community-owned renewables. Anyway, what we're looking to do is to take them through that journey, through that creation stage I mentioned for the Cap Zero, through the delivery of some new community-owned or householder-owned assets, and then a stewardship of them as they go along to make sure they're being fully utilised and fully optimised as best they can to deliver. So across those 15 communities, we're going to progress them at their pace, or more faster than the pace that we're currently going, to get closer to that full transition that we described earlier on. So almost each community have a different set of activities, but what we're trying to do is prove the system rather than prove an individual bit of it. Does that answer your question? You did break up a wee bit when you were set, or you broke up a wee bit when you were set. Reading it first time around.
I think that's answered. And I think that's probably on time now. And yeah, I really appreciate you kind of presenting and taking the questions. So yeah, thank you so much.
Thanks, Manu. If there's anything else, just you know where we are.
Okay, so I think if we can move on to the React team, you can see Johnson's come on. So yeah, over to you for your presentation.
Thanks, Manu. Okay, so this is the React project. So this is a rapid evaluation aero connection tool, and it's a collaboration between 6 partners, all sites Mapstand, who are 2 SMEs who kind of work closely together, Icebreaker 1, SGN, and National Grid. So we've got 2 networks involved. So if we go to the next slide, please.
Hi, good afternoon. From the grid edge to the grid center, I suppose, React is a transmission-focused project. So we're seeing predicted that the UK's electricity demand is set to double between now and 2050 to realize net zero targets. The volume of transmission applications is increasing rapidly, and there are large delays, on average of around 5 years for connections. And with these large projects, determining the best location for new developments is becoming increasingly important. So that spatial aspect of optimizing the location of these large developments. It's quite difficult to obtain network information for developers in that early pre-application stage. And from feedback with stakeholders, we've seen that many apply for connections just to obtain more information about the network. That visibility of the network is often quite limited. And many of these applications are being viewed in isolation when they come to the transmission network. So the demand could have a significant impact, as we see like hydrogen applications and maybe large data centers showing interest in the network and locating those large demand developments in the future. can have quite a big strategic impact on the future of the transmission network and how it's planned out. So that's the problem statement that React goes into. Handing back over to Jonathan.
Thanks, Johanna. Actually, this is over to Tony at our side, so we're going to talk about how we're looking to address the problem.
Hi, good afternoon. Can you hear me okay? Just trying to find the unmute button. So the approach that we took to build the initial tool during Alpha was really based around the idea of doing an agile build. So we built some output, we delivered that to users, we sought feedback, and then the feedback that we got steered the direction of what we did next. The mechanics of this were really about setting up an area of the database that we could receive all the experimental data. There's lots of data sets tied together. So we received that, we built a part of the platform where we're able to deploy these individual sprint outputs. And we also built a role-based access control system that we're able to give people access and also monitor how many people are actually using this that have access. So throughout the duration of React Alpha, we carved out 5 individual 3-week sprints, and each of these had a slightly different focus. So I've listed them there below. So we did power circuit and substation capacities, transmission connection status and queue, hydrogen developments and the requirements, site options and power curtailment, and then circuit and substation power flows. And as we went through that process, all the different partners and work packages were all coordinated just to make sure that the internal kind of transmission owner view and user requirements and the external requirements, so external such as hydrogen developers, energy developers, local planning authorities, permitting organizations, all the needs were understood. So yeah, best practices were applied to data governance, and then all the data sets that we needed were tied together to feed the visuals that we built. Thanks. Next.
Hello, everyone. So one of the work packages that we have delivered in alpha phase was user requirements and tool evaluation. So the objective of this work package was to engage with the stakeholders in order to define the full set of network requirements and also to engage with the developers to understand their set of user needs. So this was done in order to receive feedback on the tool functionality and usability, and also to ensure that the React tool is fit for purpose. Next slide, please. So as part of the work package 2, we have identified intended users and also target audience for the React tool, and we have engaged with them. So those included hydrogen developers, local authorities, transmission owners, distribution networks, environmental regulators, and also utilities, all of whom could be interested in the visual integration for their planning considerations. And as you can see, we have presented the tool to 49 potential users, and we have also conducted interviews in order to obtain feedback from them. So that included 25 potential users. And based on this engagement that we have had, we have produced a prioritized list of user requirements. You can see it on the right-hand side of the slide. And according to our analysis, the information on the electricity grid capacity, information on power flow, water, and curtailment is of the highest priority to the interviewed user group for the React tool. Next slide, please. I will hand over to work package 3 now.
Good afternoon, everyone. My name is Stefan Hazelwimmer from Icebreaker One, and we were looking at how to improve data sharing and interoperability at market scale for the REACT project. So two kind of main streams to our work. Firstly, we were kind of looking at the existing data accessibility and interoperability. So we conducted a sort of a data-focused deep dive into the REACT problem statement, and also looked at the primary use case of green hydrogen in the north of Scotland. In addition, we also analysed the discoverability of network connection datasets and looked at the existing what's called the open data triage process for improving accessibility. This is a thing that comes out of the Ofgem data best practice guidance. And then finally, as part of the analysis, we reviewed the data interoperability of data both going into the REACT tool and coming out of the REACT tool. And that's particularly important because potentially the tool could be used within different planning systems, for example, LEAPS, also the WINSA's projected strategic spatial energy plan. So it's really important that the REACT tool, REACT tool's data works really well with these kinds of spatial planning tools. So that was the analysis, looking at the existing situation. And in addition to that, we were looking at very much the future of REACT, driven by stakeholders. How does the stakeholders drive particular data accessibility and interoperability requirements? So within the advisory groups, we identified the scope for impactful collaboration across diverse stakeholders in order to improve risk modelling and mitigation around the network connection process. We also provided proactive discoverability of network connection datasets in order to encourage more innovative thinking around future use cases. And on the right-hand side there, you can see it's a slide, it says network connection request. That's a slide giving an overview of the different data sets involved in the entire network connection process from the very beginning of a project all the way through to when a network connection request contract is signed. And then finally, we articulated the benefits of both improved accessibility and interoperability to stakeholders, which led to some strong support for the idea of a trust framework approach. So those were two areas of work that we did during the alpha phase. And there are a number of milestones that we covered during the alpha phase. So firstly, we supported SSEN and SGN in applying the open data triage process to REACT-specific datasets. We also introduced partners to the trust framework approach, which is very much key to sharing data at market scale. We also indexed and tagged REACT datasets on the opennetzero.org open data catalog. So on the right-hand side, there's a little screenshot that shows the datasets that are tagged with the tag REACT on the Open Net Zero portal. So that's basically anyone can go to that portal and see the datasets in use in the project. So that's about sharing the data collation expertise of the project with a wider community. And then finally, we produced a data accessibility and interoperability report, which included various different guidance. And one of the key recommendations of that report was the idea of using a trust framework approach. So if we can go to the next slide, please. So probably the sort of largest problem identified during REACT in regard to data sharing was the need to bring very diverse data sets together from different stakeholders with potentially very different access conditions. And that's required to model and mitigate complex risk around the network connection process. So that was the problem. And the solution became pretty clear pretty quickly, was the need to use what's called a trust framework approach. This is a market-proven approach that's been used in open banking. And this kind of approach allows market-scale data sharing across very different diverse stakeholders. So whether that's energy companies, utility companies, environmental and consenting agencies, local and national government, and finance, we can bring all those different data sets together in a safe, secure, and robust way using a trust framework. And it does that by agreeing common rules, standards, and processes for safe, secure, and scalable data sharing. So it very much touches upon some of the challenges that have been mentioned in other projects, for example, the PRI project about streamlining data sharing. And if I go to the next slide, please. So as part of the report, we reached 5 key recommendations regarding how to improve data accessibility and interoperability in the REACT project so that it has the widest possible use across the market. So the first recommendation was about embracing market scale solutions. So to ensure that the REACT project has the widest possible applicability, the REACT project and the advisory group should work closely with Open Energy Steering Group to promote accessibility, agree common rules, processes, and legal compliance, and encourage a common rights-based approach to data access. That's recommendation number 1. And then to reduce friction, the idea was that we must embrace a trust framework methodology throughout all our work, and that would ensure that we were compliant with initiatives like the virtual energy system. And then to improve data accessibility, the recommendation was that that the transmission owners should publish the internal process diagrams describing complicated internal processes, and that would help essentially innovators see what data sets are available to figure out how they can solve particular use case problems. The 4th recommendation was about improving prediction. So we did a deep dive on the problem statement, and that led to the conclusion that a statistical model of projects should be embraced that tracks a project's estimated probability of success according to the best available data. And that would very much help much better long-term planning across all stakeholders to have a more probability-based approach to modeling risk. And then finally, 5th recommendation was about embracing innovation. So to radically embrace innovation around processes, a virtual sandbox representation of these processes with representative data should be created. And then this would allow innovators to safely experiment with innovative solutions without affecting business as usual. Those are our 5 recommendations, which you can read on the report, which is now published on the website. And I'll thank you. Pass you back to Jonathan, please.
Over to Francis at Mapstand.
Jonathan, Francis has asked if I'd cover his slide for now. Something's come up, so yeah, if you don't mind, I'll just talk on Mapstand's behalf.
Sure.
Okay, so yeah, so this is really tying together, large numbers of data sets that are out there. These are, in most cases, these are open data sets. Some of the challenge with this is that the way that the assets are called and how they're identified, how they're spatially described, is not entirely consistent between different data sets. So there's a big challenge there in tying these together and adopting common naming so that a pipeline can be built, and then as the data changes, an aggregated view of that data can be built. So this includes current and future circuits, substations, generation schemes, which included wind farms. Also includes battery storage projects, pumped hydro. It also integrates information about curtailment from balancing mechanism, and it also includes power flow data and headroom information from the transmission owner direct. We also include information in there about hydrogen infrastructure, gas distribution lines, supply of hydrogen, potential demand for hydrogen. Yeah, I think that pretty much covers it. Should we go to the next slide, please? Okay, so here I've got an embedded video link. I thought for work package 5, where we talk about the experimental output that we made, probably better to show this as moving pictures rather than screenshots. So I've just got a silent 2-minute video here. If you'd mind pressing play, please, and I'll talk over it. Okay, so to start with, you can see how the individual sprints have been deployed. There's 5 of them. The first thing we're showing here is the ability for the user to be able to switch and understand the transmission circuits according to voltage, power capacity, power flow, headroom over a number of years. And we style the circuits where the width is proportional to the capacity. And we used a color scheme to indicate whether there's lots of headroom or not much headroom. We also built this optional flow map layer, which is it's almost like a hub and spoke representation of how the schemes are connected or queued to be connected to substations. And then the visuals aggregate information per substation on what's connected and queued to be connected at both transmission and distribution level. And then the table underneath can be sorted according to status and year. So we've got optional curtailment information. So let's say this comes from the balancing mechanism. We're going to look at multiple years. The ring's proportional to the size of curtailment, and there's a pop-up there that gives statistical information. Okay, water was one of the big issues that came through in almost every conversation in the context of hydrogen. Some of the things were important was how much flow does each river system have? Where are the boundaries? What other abstraction licenses could there be in a river system? So we experimented with that for feedback, and then we also experimented with different base maps and some additional context layers to understand whether projects kind of make sense. And the one I've got on the screen at the moment was wind speed, peat grade layers. And these are really designed to enable some of these early stage pre-application conversations about whether projects make sense. So that's just a really quick run through of some of the outputs that we built during Alpha. Okay, next slide.
Yeah, so to kind of tie it all together, we obviously through Alpha we dedicated some time and resource to identify what the benefits are to the consumer, because ultimately that's where we kind of can show the real value in the project. So we see reactors having a number of benefits. One is we can potentially reduce curtailment by looking at the network more holistically rather than in an ad hoc basis when considering connections and these pre-application discussions. And that has the kind of knock-on effect of the reduction of curtailment also will reduce the use of synchronous power generation to balance that curtailment. So there's the reduction in carbon emissions associated with that, less fossil fuel generation. Also, with this total view of the network, through the tool, there's potential to take out some of the network reinforcements or the potentially reinforcement that's planned when it's strategically being considered, and this has a knock-on effect of reducing the transmission network use of system costs. And I suppose the fourth benefit, which is financially probably the least, but it's still certainly of value, is there's a lot of what were so-called zombie connection requests just by developers who are kind of unaware of the network and the ins and outs of the running of it, and so they put in applications just to understand what they're really to kind of understand what their options are. So through this tool, that would kind of negate the need for that, or the need for so many, and take away the resource required to consider those requests. So collectively, the benefits are shown on the right-hand side over that period, and we can see those obviously benefits are based on a number of assumptions, but it gives you some potential, and we've looked at sensitivity factors so that we can see there's an upper and lower benefit, and also within those figures we've included the cost of the cost of React through the various phases. And I think in conclusion, the developers will have a greater awareness of the opportunities available to them, through the use of the tool, and that can only help them and also help the networks in parallel with that. So if we move on to the next slide.
So throughout the alpha phase, we engaged in a lot of stakeholder engagement with local authorities and developers. And one thing that came out, especially in the context of hydrogen, is that water availability is a huge consideration for these developers. So water as a layer we kind of developed through Alpha, and as Tony showed in the video, you can see the water flows available on the map, which just again brings together all those vectors which developers are considering in that pre-application phase, and helps make that decision process in that early development stage. So yeah, the water was a layer we developed. And another thing that there was quite a lot of engagement during Alpha was to understand exactly how React fits in with SSENT's existing digitalization processes. And there's a migration in software in SSE at the moment for the PowerFlow software. So fitting in with that, not wanting to duplicate any of the work, but also making sure that whatever React builds will be compatible with the outputs of that new software. So there's a lot of engagement there, and as a result, changes in the considerations of data structures being fed into React to be in line with the TO models. Another thing that evolved during the alpha stage was the original geographic scope. So a lot of the data links that are behind React were already being created for kind of Scottish-wide or national-wide data sets, and it was decided to expand the visualization, which was initially just the mainland north of the BNOT boundary, to Orkney and Shetland, because those are areas with a lot of interest at the moment, kind of in SSEN for network projects. And it just showed how, also for us, it was a good use case to see how the tool scales, and it was quite successful to just scale it up to Orkney and Shetland in a relatively short time period. So scalability of the data. And as Tony showed as well, we experimented with a few additional base maps of different visualizations to highlight different resources and vectors on the map. Yeah, that's some of the developments. Next slide, please. So in terms of future direction, a lot of this engagement as a development through Alpha has brought a few things we want to explore more in beta. So all of that is captured in quite a detailed statement of requirement report we've put together. Like to scale the tool further to show the Scottish transmission network or even the UK transmission network, because a lot of the data sets underlying it are kind of at that scale already anyway. So expanding to other technologies. So hydrogen was definitely the case study for the alpha stage, but a lot of the information displayed on the map is relevant to other technologies as well, and to other demands, large-scale demands looking to connect to the network. So having a few more customized views for these other technologies, and creating these technology heat layers or user stories for different technologies, where you can define and customize the map to show, as a hydrogen developer, these are the layers of interest, or as a data center developer, these would be layers of interest, or the wind layers. So kind of creating these different views that are relevant to different users of the tool, and letting the users customize those views as well as they use the tool to provide more of an analysis-based layer that shows opportunities for those technologies. Yeah, and another thing that came kind of to light during Alpha is that the visualization was a big focus, but we've come to realize that the data created for this visualization also has an incredible value to users, and that being able to export that data in structured formats is in itself a deliverable of the tool. So yeah, that's me. Next slide, please.
Yeah, so based on everything that's said and what Johanna intimated, yeah, we've collectively as a partnership decided that we're keen to submit a beta phase application, which is what we're going to do next month. Key areas of focus that we've identified are, again, which has been touched on by Stefan, for example, the trust framework. So really to enhance data access and data interoperability. Unification of data sets is a huge piece of work that MapStand are going to be focused on. And we're going to, one thing I didn't mention is, the intention is to build the tool for the UK network, for the entire UK network. Obviously, we focused on Northern Scotland for Alpha, given the time constraints. And we want to ultimately commercially roll out the software in whatever form which is yet to be defined. So we've got a commercial plan factored into the plan for beta. So that's going to be a key part of the work, certainly towards the latter end, but running from the beginning to some extent. keen to strengthen the partnership, so to ensure it's obviously suitable for the UK network, which is our ambition. So we've got NGET and SGN gas network already involved, but we're keen to involve ESO, or soon to be ESO, and SPEN throughout, who we did speak with through Alpha, and targeting more involvement in Beta. And we're kind of in discussions with both of them to how they can get involved, and the scope of their work to do that. But we're keen to invite anybody who's interested to join our target group, which will be a part of the work in Beta, so that we can really ensure that the tool that we develop has the widest appeal and is obviously suitable to help drive down net zero. But yeah, so that's everything from us. So are there any questions?
Thank you, Jonathan and team. Yeah, I don't think there are any questions, and I think we've kind of run over a little bit into a Q&A time. So just wanted to kind of finish the session on time. We kind of leave it there, but thank you so much for presenting. I think if there's any questions in the chat, you can probably pick it up.
Thanks, Manny.
Yeah, thank you.
Thanks, everybody.
Thank you.
If I can please invite the Indus team for our final presentation. So we'll be finishing on industrial decarbonization and coordination of industrial decarbonization models. So Lucas, my hand over to you.
Yeah, hi Manu.
Okay,
Good
hello.
afternoon, everyone. So is that the last presentation for the day? Or
Yes.
it is? Okay, cool. Let's try to close in the best way possible then. So good afternoon, everyone. My name is Lucas Varas. I'm Innovation Project Lead at UK Power Networks, and along with Eleanor Bell from Guidehouse, we're going to present today in this project and all the interesting things that we've done during the alpha phase. So the presentation will have an overview of the project and the problem statement, then the findings for the alpha phase, and what are the next steps. If we can go to the next slide, please. I think it's 2 slides because, yeah, another one. All right, so first of all, the project was conducted in collaboration with Guidehouse, M3MAS, Ameresco, Peterborough City Council, New Anglia, LEP, and Caden. So you can see there is a wide range of different stakeholders that were really useful during the project because of the problem that we're trying to address. But what is the problem we're trying to address there? It's around decarbonization of industry. And the base is that when industrial sites decide to decarbonize, then it's most probably going to happen in isolation at the moment. That means that there will not be any sort of collaboration with any other sites that are nearby. And for that reason, there will be no sort of diversification of the electricity generation that they require there, and also the electricity requirements and power requirements that might require, which will also result in high peak demand and potentially an upgraded electrical connection request that will be really high and potentially really costly for them to proceed with. That means that the reinforcement will also be, let's say, quite onerous for the DNOs to pick up in the future, because when you have this kind of industrial sites with the energy consumption that go decarbonizing one or the other, you need to be smart in order to be able to deal with the decarbonization requirements in the best way and most cost-effective way possible. So what are we planning to do? What are we actually suggesting to do as part of Indus? We're suggesting that the decarbonization of these sites will actually happen in collaboration, in a coordinated way. So when you have adjacent sites that decide to decarbonize at some point, then they will do it in a coordinated way. And what we mean by coordinated way, we mean that different industrial sites, commercial businesses, energy hub providers, regional energy strategic planners, also known as RESPs and DNOs, they all come together, work together to decarbonize those sites. And this will be through deployment of shared infrastructure, which will eventually reduce the overall capacity demand on the network. So in this project, has worked quite closely with the different stakeholders, which Eleanor is going to talk to you about later on, in order to develop a suggestion for a new commercial business model to enable this kind of Indus sites. The Indus site can be seen on the screen, which is the graph, the schematic on the right. At really high level, how it looks like: you have DNO or IDNO providing the electrical connection to the site, and then you have some behind-the-meter solutions, which could be different kind of renewables like battery, solar, heat networks. And then after this behind-the-meter energy hub, you have some private wires that are connected to each one of the industrial businesses. Our suggestion is that this overall Indus solution is pushed by RESPs, and this is an overview of what an Indus site looks like. I will now pass over to Eleanor to tell you more about the findings that we got during Alpha.
Thanks, Lucas. If we could just go one more. Oh, there should be one on user needs, slide number 5, I believe it was. I think you skipped over it. Yes, perfect. So as Lucas said, we had a lot of project partners in the Indus team, but in the alpha phase, we went broader than just us, and we spoke to a lot of different stakeholders, including other DNOs, IDNOs. We spoke to a lot of industry of different sizes, so really large, intense energy users who have sophisticated energy teams themselves, and then also smaller businesses that don't know a lot about energy, but obviously want to decarbonize. And from all of the discussions that we had with industry around the problem statement and our solution from the discovery phase, we were able to further identify or refine the challenges that they were really experiencing and refine our commercial solution to fit that. So the challenges that came up from all of this engagement was around a lack of information sharing across companies, customers finding it difficult to understand the technical language of the energy industry, while the DNOs needing the technical certainty, then also limited visibility of live and future network information. So that was from the customers, but also from the IDNOs, DNOs, heat networks. Everyone agreed that collaboration is essential, but there's not always a clear driver. That was particularly acute for the smaller businesses. And the ones that had tried to get changes to their energy capacity had found the connections process quite time consuming. And overall, there was an impression that electrification is expensive and uncertain for the big industrials. All right, if we move on to, so with all of that information, we then looked at what elements we would need in a commercial solution to address those challenges. We split it out into some network-focused elements and then customer-focused elements. And so Lucas has already talked through the customer focus side, which I'll come to in a second because it relates to the next slide. But first of all, the network focused elements. So during the alpha phase, we were hoping to be able to take energy consumption data from both the electricity and gas networks for industrials and compare the energy use and what that might transition to as they decarbonize. What we identified was that across the local authorities, GDNs and DNOs, there's a lot of challenges in sharing data and also challenges in how the industrial data is captured and stored. So one of the things that we identified as a need for the commercial solution was to improve forecasting across these 3 types of organizations. And that would start with gathering and then sharing the relevant energy data and developing pathways for industrial decarbonization that would then inform where on the energy networks they might experience constraints in the future. And that would then enable them to prioritize which industry they need to engage with in order to manage the potential spikes in demand ahead of time. So once they've done the forecasting, they would align the forecast with their network planning and encourage clusters where they can see these spikes in demand occurring in the future. So the idea of the cluster, as Lucas said, was that you would have behind the DNO or iDNO, you would have an energy hub that is managed independent. Well, it could be managed by some of the bigger industries. They did indicate interest in doing that, but for a lot of the cases, it would be managed by a third party, so that the energy needs of each of the businesses, Indus businesses, are met without them having to be super involved in becoming energy experts. That should mean that they have less of an infrastructure investment. They also can provide flexibility services to the grid, and their peaks are diversified, so it's less onerous on the networks themselves. In response to the need to have someone drive collaboration, we initially thought it might be local government that would do that, but given the need for energy expertise, particularly with some of these smaller industries and commercial businesses, having someone like the RESPs who has that energy expertise, but also looks across gas and electricity, was found to be the most useful, or the best equipped candidate to do that. If we move to the next slide, so we developed this kind of commercial idea, and then we thought, okay, we want to test this with some real businesses. And so we ran a screening. We had a set of criteria, and we screened a bunch of different businesses in Norfolk and Suffolk, which was where our partners, New Anglia and Peterborough, were based. And so we screened businesses from there to identify where we might have an opportunity for collaboration, and we came across Lotus and Hethel. So Lotus is a car manufacturer and Hethel is an innovation centre. They're right next to each other, and they have a really good relationship with each other, which was very helpful for the collaboration part of things. They both have significant expansion plans that are conveniently right next to each other, and they also need to decarbonise their existing sites. So we went and met with them to understand their energy needs and test out how the different contractual arrangements might work. And we identified that if they took a clustered approach, they could save either 11 to 94%, depending on if they go hydrogen or electrification, but they could make significant savings in KVA, and reduce the pressure on the grid. And then we also identified the CapEx savings that they could make from collaborating. And then there's an ongoing OpEx benefit as well. These companies both have quite aggressive decarbonisation targets, so it was good to get in and build relationships with them now before they need to upgrade their capacity connection. All right, next slide, please. So having done the sort of bottom-up Lotus and Hethel, what would it look like on an actual site? We also wanted to look at what the more general benefits would be across UKPN's license area and then also across GB. So we found that there was 190 million in potential benefits. So that's cumulative discounted net financial benefits by 2050 from avoiding 1,491 MVA of network reinforcement. So that comes from the reducing the peak demand that we were talking about. Associated with that is a reduction in electricity grid import, so you can make some carbon savings as well. And then because you have to build less network, you also reduce the embodied emissions associated with industrial electrification. So this was done through identifying 48 industrial clusters in UKPN's license area. As I mentioned earlier, data was a bit of a challenge. So we did, I think that was something that we really learned through doing the cost benefit analysis, getting data on industry, where it's located and what its energy uses and emissions are is quite challenging, particularly when you're getting down to some of the smaller emitters. But we did identify 48 clusters, which covered 54 industrial anchors. And then each of those clusters includes commercial businesses as well. We then extrapolated that out to GB and found 193 clusters. But I would say that this is a conservative estimate because, as I mentioned, when you get down into the smaller industrials, it's very hard to get the energy consumption data and emissions data. So this really does capture the larger industrials rather than all of the teeny tiny businesses that might be out there. Okay, moving on to the next slide. I'm going to pass back to Lucas.
Thank you, Eleanor. So just to wrap up the whole session, I think something's funny with the slide, but yeah. Anyways, so we've actually completed the alpha phase. What is the plan for the next step? We are suggesting to go for a network innovation allowance project, and then potentially go for a beta phase application next year. The reason for that is that there are still some uncertainties that we're trying to do a bit more work. And in order to go for a long duration project like a beta phase project, then we believe that it's better to be more prepared. So the areas that we're going to focus during the potential project we're going to scope over the next few months is to develop a data sharing agreement between DNOs, gas networks, local authorities, and industrial sites in order to do a sort of industrial mapping of all the different sites and understand how they consume the energy. Then we're going to develop some decarbonization pathways for different types of industry to understand what are the likely technologies that they're going to use in order to decarbonize. And after we gather the industrial mapping and the decarbonization pathways, we're going to incorporate those data, this information into DFAS and the strategic forecasting system, which is used to plan the network and understand what will be the sort of load requirements for the next 30 years or so. On top of that, we're going to continue engaging with various stakeholders. So we mentioned RESPs. We had a few discussions with RESP, but we need to do a bit more work there in order to identify whether they are the most suitable, let's say, party in order to take over the role of coordinating the Indus sites. We're going to continue engaging with Ofgem and Indus on any policy and regulatory changes that might be required. And finally, we're also going to continue engaging with the shortlisted sites that we gathered during the alpha phase in order to understand the requirements a bit more and also scope any potential beta phase demonstrators in case I will proceed with the beta phase in the future. So that was the Indus project and what we've learned during the alpha phase. Thanks a lot for your time and attention. I'm happy to take any questions.
Thank you. Thanks, Luca. Thanks, Elena. I think, yeah, I mean, this is a great, I think, project to kind of finish on that shows kind of how much system benefit and wider economic kind of opportunity can be unlocked through energy network innovation. So, yeah, really great to hear a presentation. I've not seen a particular question yet. Let me just check. But I had one just out of interest. In terms of some of these shared assets that you're planning, how are you thinking they might get financed or invested in? Is it like some kind of special purpose vehicles? How might that happen?
Yeah, so the idea of special purpose vehicles did come up as one of the options. I think we did come up with a range of different options. So some businesses have a preference for owning the assets themselves and would fund them. Others were more interested in setting up a special purpose vehicle, like you said, and having equal ownership. And when we engaged with some developers, and energy providers, they actually indicated that they would be happy to finance the whole thing themselves and then recover the costs of the assets through the charges to the users. So it really depends what the arrangements are. We identified a few archetypes, but it does depend on the business's preferences and it's, I guess, risk appetites is the thing there.
Okay, understood. Just sort of, so is that, I remember there was, I think, a few models where communities themselves were planning to create like an IDNO and then they invest ahead of kind of need and then they recover the money through user service. Is that a model that you were talking about, like the industrial cluster itself becomes, or are you still thinking there'll be external third parties coming in? And...
I think so some of the third parties that we spoke to would want to own it, operate it, and then potentially would and recover the cost through the energy charges that they provide. Other industrials were actually interested in owning the assets themselves. And they may, I guess, recover charges from their neighbours, but that wasn't worked through in great detail. I think it would depend on the different interests of the businesses.
Yeah, I was just wondering how the metering and commercials of that work, but I guess that's future work to consider. Okay. And in any of those shared assets, because you have things like storage, etc., is any of that planned to make revenue for the clusters, or would they only solely be used for the clusters themselves and they will not be participating in any markets?
Yeah, so the idea was that they would participate in flexibility markets at least. We didn't look at ancillary services or anything more complicated than that. But I think where the clusters were or the industrial businesses that we spoke to were interested in potential revenue streams outside of just meeting their own energy needs.
Great. There's one question that's come through, which is from Stefan. What approach are you adopting in terms of creating a data sharing infrastructure during the next phase of the project?
I think the initial idea there is that there will be a platform potentially on UKPN's website where you are able to provide access to specific users. So any sort of data that we're going to be shared that will be protected. So that's the idea for now. On top of that, what we're trying to do is identify any sort of databases that have the data for the industrial size of need, or we even think the approach of getting in touch with the big anchor sites that we believe that will actually form part of potential Indus clusters in the future and get the data from them. So that there are quite a lot of different ideas with regards to how we're going to do it, and it's something we're going to explore further in the next phase.
Thanks, Lucas. And one last question, just in terms of risk and resilience, did you kind of analyze any implications for resilience or security of supply when industries who may have quite critical process share infrastructure, or were they kind of broadly happy with potentially, I guess they have some specific requirements of when the asset needs to be available for them, or they need to price that into the asset. So yeah, did those conversations come up?
Absolutely. I think whenever you talk to an industrial, they say they're happy to do something smart, but you cannot interrupt my output. Like I need to be producing what I'm producing and you cannot interrupt that. So that definitely came up and I think is most applicable in terms of the flexibility services, but your point around risk and resilience and tying themselves potentially to their neighbours did come up as something that would need to be explored further. The industry that we did speak to, though, I think the overarching message that we got was that they are all puzzled and perplexed about and don't know what the right path is for them for decarbonisation. And they're also really unaware of the network implication of decarbonisation. So even if they did pick, like they might do all of this work to identify that they want to electrify, and then they go and approach the network. And originally we were looking at, would we intervene in the connections process? But actually from the conversations that we had, we identified you need to be intervening before they've made an application to understand and shape what their decarbonisation pathway might be, because by the time they've put in a request, they've spent hundreds of thousands of pounds potentially. So I think that is one of the earlier focus areas, but risk and resilience, yeah, absolutely on their radars.
Thank you so much. Yeah, I think that we've come to time. So yeah, thank you so much for the presentation and the time for kind of answering the questions. That brings us to the end of the session. So I'll kind of thank Lucas and Elna there. Just in terms of to remind everyone, you have access to the other sessions as well. So we've covered a broad range of topics this week, everything from system resilience to flexible energy system to asset efficiency, cross-vector approaches, etc. So if any of this kind of piques your fancy, please do stay tuned for the videos that get shared as well, so you can kind of look back at some of the project presentations. So these are immensely useful if you're working in this space, or if you want to collaborate, or if you're thinking of doing work in this. So please do reach out. And I think just in the last slides, just from a SIF perspective, because there's so much going on, the Ofgem website is where we publish updates. Please do sign up for our newsletter. We won't spam you, but you get the most kind of up to date. Our annual report is a very good place for like quick case studies. Our blogs, we've got a new podcast out as well, an episode. Sorry, the podcast has been running for a while. And if you have any questions on any of this that we presented, reach out to sif_ofgem@iuk.ukri.org. Myself or my colleagues will get back to you. But thank you so much for your time and kind of attending all of these sessions, and we really hope these have been useful. Take care and have a good evening.